Evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to my next training video, and we're now going to take a look at air masses. Now, air masses are a very important aspect of meteorology. We have differing air masses that move in and out of an area, and when we have these air mass changes, we usually have a much different feel to the air as far as temperatures, as far as your humidity and dew point levels. And so we're going to go ahead and examine this interesting topic of air masses in this training video. All right, so first of all, let's just do some general facts about air masses. First of all, about 50% of heat transfer that occurs on Earth is exchanged by air masses, transporting energy from the tropics to the poles. This has to do with the fact that the tropics are heated much more than the polar areas, and as a result, we have to take the excessive heat from the tropics and move it towards the poles to kind of balance things out in the atmosphere. And air masses do 50% of this work. The other work is done by ocean currents as well, the warm ocean currents that run from south to north. They also do their part in exchanging excessive heat taking that excessive heat from the tropical areas and moving it to the polar areas. Now, air masses are large bodies of air. They cover hundreds of thousands of square kilometers. And the one thing about air masses is that the horizontal, temperature, and moisture characteristics are generally uniform. So generally uniform temperature and moisture characteristics. Air mass boundaries are referred to as fronts. And in the next training video after this one, I've got another video ready to go that will cover fronts, the different types of fronts. But air masses are really just varying air masses are separated by fronts. Additionally, when we talk about air masses, we have to talk about something that's known as source regions. Now, these are the large areas where these air masses form. The terrain or the topography should be relatively flat and of uniform composition. So we generally look for air mass to form in a source region. We look at a huge area, for example, of a snow-covered ground, or perhaps a vast ocean, a big area covered by ocean. We want flat terrain because we don't want a lot of mixing. We don't want a lot of air movement in the vertical in relation to mountains. We want that air to kind of just spread out horizontally over large distances. Source regions also contain stagnant atmospheric circulation. We want light winds in an air mass source region. Too much wind, specifically stronger winds, is going to mix the atmosphere up too much for air masses to really form. So typically what we see with source regions are they are dominated by high pressure. The longer the air mass, the longer the air remains stagnant over this source region, the more likely it will obtain the properties of the surface below it. Okay, so now we have an idea. We looked at a couple things here so far in the training. We looked at, air masses in general, some interesting facts about air masses. We looked at what source regions are. These are the areas on Earth where air masses form. Now we're going to talk about the different air mass types, air mass classifications. And there's four main air mass classifications to consider. There's polar, tropical, continental, and maritime. With polar air masses, this is generally going to be air masses in higher latitudes. The temperatures must be very cold for a strong air mass to form, and the polar air mass is designated by the capital letter P. Tropical air masses form in very warm climates. They are designated by the capital letter T. Continental air masses form over land areas. So continental, think land, designated by the lowercase letter C. And then maritime form over large open ocean areas. And maritime air masses are designated by the lowercase letter m. All right, so now that we kind of have an idea of the types of air masses, let's go ahead and look at each one of these air masses a little more specifically. All right, so first one we're going to look at is continental polar, and it is abbreviated by a lowercase c, capital P. Okay, the lowercase c means continental or land-based. The capital P means polar, so it forms at higher latitudes. All right, so let's look at some interesting facts about continental polar air masses. First things first, they form at high latitudes over land. Continental land, polar high latitudes. The three source regions are indicated here on this particular map. We have a continental polar source region over central Canada, the Northwest Territories as well. We also have a continental polar air mass over Greenland. And then we have a continental polar source region generally located over Siberia. Now let's examine continental polar air masses in the winter, and then we'll look at continental polar air masses in the summer, the different characteristics between winter and summer for continental polar air masses. The temperatures in winter with this continental polar air mass are near the surface range from -20 to -40 degrees Celsius. This is a very cold air mass. Due to the very cold temperatures, the air cannot hold much moisture. It's very dry. So the drier or the colder the temperatures, the less the air can hold as far as moisture goes. So the continental polar in winter, very cold, very dry. You may be around the house in the wintertime when this air mass comes in. You kind of get that static electricity, that shock when you touch something because the air is so dry. Continental polar air masses in the winter are responsible for cold weather entering the U.S. They generally bring clear skies and good visibility. Now, I've seen these coming in and out of the mid-Atlantic, and continental polar air masses with a nice strong Canadian high pressure coming in just produce some amazingly clear, really crystal clear blue skies. The air is just so clean. You may almost feel like the air is a little bit crispy when a continental polar air mass moves into your area in the winter. They are associated with these very strong high pressure systems in the winter that come out of Canada. Meanwhile, continental polar air masses in summer. What is CP air masses like in summer? Well, obviously with the summer season, the temperatures are not that cold. The air mass is still dry, so in many cases in the summertime with continental polar air, you kind of get that break from that oppressive humidity. After a cold front moves through, the high pressure builds in from Canada, and you get a drier air mass with lower dew points, which makes it feel much more comfortable outside when continental polar air comes in the summer. The average surface temperatures for this time of the year in the summer range from 10 to 25 degrees Celsius. So 10 Celsius is about 50 Fahrenheit, 25 Celsius is 77 Fahrenheit. And because of such dry air in place with this air mass, you have a large daily temperature spread between the high and the low temperatures, between the morning and the afternoon. Continental polar air mass in summer is going to produce excellent weather. Typically, you'll see these fair weather cumulus clouds pop up and excellent visibility. I mean, this is a very dry air mass, so you're not going to get much in the way of precip here. You're not going to have any kind of reduced visibility, and only during the heating of the day, you're going to see these scattered, flat-looking fair weather cumulus clouds. And continental polar in summer is associated with high pressure, but that high pressure is just not going to be nearly as intense as the wintertime version of CP air mass. For one, the sun is still heating the underlying land, and so the pressure it can't get, the underlying land isn't very cold, so the high pressure is not as strong as the winter. Continental Arctic air, abbreviated with the lowercase c and the capital A letter here. This is a colder version of a CP air mass. The source regions for continental Arctic air include the North and South Poles. This is extremely frigid air in the wintertime. And by the way, you're only really going to see this in the Northern Hemisphere in the wintertime. They have the same characteristics, continental Arctic air, as CP air mass, but are more intense. This is going to produce some of that record-breaking cold temperatures into the United States, and it's going to be very dry. It's responsible again for the bone-numbing winter cold waves that sweep across the Great Plains. And at times, continental Arctic air mass moves as far south as the Gulf of Mexico and Florida. These are the air masses that clear the Gulf Coast, get down into Florida, and a lot of agricultural folks have to basically spray their orange orchard areas to prevent their orange crop from being frozen and destroying it. So they do, again, continental Arctic air does bring this record low temperatures in the U.S. Right, let's talk about a summer-only air mass. This is continental tropical. Lowercase c continental, capital T tropical. Continental referring to land, right? As I mentioned, that's an air mass that forms over the land. The only real source region for continental tropical air in North America is going to be northern Mexico, just south of the U.S. border, and also the U.S. desert southwest. Very common in the summer months. Globally, continental tropical air masses, they're found over the Sahara Desert in northern Africa, the Southwest Asia area, and Australia as well. Australia, we're really talking about the outback in their summer season. It's very hot and dry. There's not many clouds in this air mass because it's so dry. An upper level ridge usually produces some downward vertical motions. It keeps the sun just beating down on the landscape. In a lot of cases, it's these desert areas that see this continental tropical air. The daytime temps, by the way, range from 35 to 46 degrees Celsius. This is no joke. This is some serious heat. We're talking triple digit in Fahrenheit scale, triple digit plus heat. Areas like Phoenix, Arizona for the United States as an example. All right, so continental tropical air masses, here's their source regions in the upper left-hand graphic, denoted in this yellow coloring. So you see, this is mainly going to be a summertime air mass only, okay? In the northern hemisphere summer, it's going to form across the desert southwest. Continental tropical air forms over northern Africa. The Sahara Desert sits about right here. And then you've got also over Saudi Arabia, the Middle East area there. Continental tropical air forms there in the respective summer season. And then over in the outback of Australia in their summer season, okay? The CT air masses are normally very dry, like I mentioned. You can get these thunderstorms to develop, but they occur with very high cloud bases, 8 to 10,000 feet above the ground. And that's really because the air is so dry in the low levels of the atmosphere. Even though this land surface is heated intensely, as the air rises, it takes a while for that temperature to cool to the dew point because there's such a large spread between the temperature and dew point at the surface. So it takes a while for the air to get saturated and for you to actually see the cloud base. And it can be 8 to 10,000 feet above the ground. And in the certain times of year, such as July, when you get the southwest monsoon in the U.S., southwestern U.S. monsoon, you actually get very high elevated, they're called high elevated thunderstorms to develop. Okay, so this bottom left graphic kind of just, again, re-emphasizes the fact that you get these thunderstorms to form, but the bases are at about 8,000 feet above the surface. Maritime polar air masses. Let's talk about these type of air masses. The source region for these is the cold unfrozen ocean areas. In the northern hemisphere, the source regions are going to be both the North Pacific and the northwestern Atlantic oceans. In the southern hemisphere, your source regions for maritime polar air are the ocean areas, generally around the tip of South America, as well as north of Antarctica. And what is a maritime polar air mass? It's generally a cool and kind of damp air mass. It's cool and moist. So let's look at this graphic here on the right. Anywhere where you see the yellow shading is where maritime polar air masses generally form. These are their source regions. So the northwest Atlantic, southwest of Greenland, kind of like southwest there, or southeast of Greenland, southwest of Iceland. If you go to the southern hemisphere, you see it right here. The southern tip of South America has maritime polar air masses, as well as this area just to the north of Antarctica. Let's now continue to talk about maritime polar air. The formation in specifically the northwest Atlantic in the wintertime. You'll get a continental polar air mass to come off the eastern portions of North America over the northwest Atlantic. And there's a transition that occurs from continental polar cold and dry air. Once it moves out over the unfrozen waters of the northwest Atlantic, it picks up some of that moisture from the ocean surface as it moves off the land area. That ocean moisture then changes the CP air mass by adding, that moisture in general and warmer air in the lower levels of the atmosphere. And we get a rapid change from continental polar to maritime polar air masses that occurs as a result. During the winter, the maritime polar air mass may bring low clouds and rain, bring snow to higher elevations, to coastal and inland areas, has heavier precip associated with it occurring on the windward side of north to south mountain ranges. And in the summertime maritime polar air, this is the air mass really that produces that thick, very thick and dense coastal fog and low clouds, specifically off of New England. Maritime tropical air. Now let's talk about this air mass. It's very warm and humid. Notice how it's abbreviated with a lowercase m for maritime and a capital T for tropical. But this is a very warm and humid air mass. This air mass is what makes it feel so muggy along the east coast of these continents, these areas here. East coast of North America, the east coast of Asia. Just maritime tropical air it dominates the east coast of these continents in the summer season. The source regions for maritime tropical air over tropical and subtropical oceans. It's sometimes referred to as equatorial air mass. It maintains its properties year-round, by the way. It's responsible for the oppressive summer heat, humidity, and the thunderstorm development, those air mass thunderstorms east of the Rocky Mountains. Let's look at the source regions over here on the right with this graphic. Notice where this maritime tropical, these source regions, where the empty air is forming. Again, over the tropical, even extending north a little bit into the subtropical area here on the northern edge of this. Particular oval shape here across the Atlantic, across Mexico, but really it's over the water it's going to form. And generally, you see it here over the western Pacific as well, over those waters, maritime tropical source regions. All right, maritime tropical, the surface temperatures in the winter are going to be cooler, generally ranging from 21 to 27 degrees Celsius. But in the summertime, the temperatures go up. They average 29 to 35 degrees Celsius. And with this air mass, it's very moist, it's very unstable, and thunderstorms, usually in the afternoon or early evening, are the results. And here is an air mass summary. This might be my last slide. Oh, yep, this is my last slide. I got another one to show you what's ahead. But just to summarize the air masses, what we discussed in the video, you have different source regions of air masses, right? You have a continental air source regions, abbreviated by lowercase c, form over land. These air masses, maritime, lowercase m, form over water. And then you combine continental and maritime with some of these other characteristics of air masses that involve the temperatures. Polar air masses, capital P. Tropical air masses, capital T. And here you go. So if we combine continental, polar, land-based source region, polar air mass, it's cold and dry. Continental tropical, remember this is summer only. Continental, C, T, tropical, hot and dry air mass. Over the water, we have maritime polar air mass, it's cool and moist, lowercase m, capital P. And then warm and moist, very muggy and oppressive, we have lowercase m, capital T for maritime tropical. All right, that wraps up the video on air masses. They're very, very important, specifically as we get into the fall, right on through the spring seasons. In the summertime, the cold fronts are much weaker, and really the air masses don't change a whole lot for many locations. Unless you go further north to northern New England and along the US-Canadian border, there's just really not much in change of air masses during summer season. But once you get to the fall, specifically the winter, and then into the spring, air masses really do a lot, results in a lot of changes in the weather for us. So just wanted to point that out. So still to come, training ahead, we'll be talking about weather fronts in the next video. We'll talk about, I broke severe weather fundamentals into 2 separate training videos. We'll talk at severe weather fundamentals, the focus on thunderstorms and tornadoes, and then we'll move into severe weather fundamentals. This will be part 2. And I'll cover heavy precipitation events, snowstorms, blizzards, etc. And then there's more even after that I'm lining up in the summer series here of training on the Spot on Weather YouTube channel. I appreciate everybody's subscription to the channel. I'll keep the videos coming, the training videos. I really hope you're getting a great education out of these videos. And even if you do, maybe you've already had a basic meteorology course, right? Hopefully this is a nice refresher type of video series to kind of, I like to utilize the summer to really refresh up on knowledge. This is very basic and fundamental meteorology, make no mistake about it, but it's also very, very important topics of meteorology that really are responsible for changing the weather quite a bit from day to day. So I really hope you enjoyed the video. That's all I got for now, everybody. Until next time, take care and God bless everyone.